Lesson 64, identify, write, and graph inverse variation. Earlier in the year, we went through direct variation. Now we're going through inverse variation. So the equation is going to be very similar, but the order or the setup is going to look a little bit different. So inverse variation is where y varies inversely as x, or y is inversely proportional to x. So the setup would be y equals k divided by x. Remember direct variation was y equals k times x. So now when we're working with inverse, we're going to be looking at y equals a constant divided by the x variable. And then we're going to be looking at the product rule for inverse variation. And the product rule for inverse variation says if x1, y1 and x2, y2 are solutions of an inverse variation, then x1, y1 equals x2, y2. We're going to have ordered pairs or groups of variables that are related to each other. And they're going to be equal to each other because the constant is the same. So let's take a look at an example here. So here the inverse variation says y is equal to the quotient of the constant and variation k and x. So again, just keep that in mind. So it says determine if it's inverse variation. So we need to get it into this format. So to solve for y here, I'm going to multiply by 6 on both sides. And I get y equals 6x. And y equals 6x, that is actually direct variation. So no, this is not inverse variation. The second example, xy equals 5. To get y by itself, I divide by x on both sides. And I have y equals 5 divided by x. So this one is direct variation because I have my constant divided by my x variable. Next slide, determine if it's inverse variation. So I solve for y. I don't want y in the denominator, so I'm going to multiply by y first on both sides. So now I have yx equaling 36. And now I can solve for y by dividing by x on both sides. And I get y equals 36 divided by x, which, yes, this is inverse variation. Last one here. Get y by itself, I divide by 3x on both sides. And I end up with y equals 9 divided by 3 is 3. I have x still in the denominator. So yes, this is inverse variation. Our second examples today using the product rule. And the product rule again is this. x1, y1 equals x2, y2. So for every ordered pair in an inverse variation, y times x gives you your constant. And so when you're looking at the product rule, this xy and this xy are equal to each other because they have the same constant. So it says if y varies inversely as x and y equals 3 when x is 12, find x when y is 9. So this is your y1, x1, x2, y2. So you just plug in your numbers into the formula that they have here. 12 times 3 is 36 equals 9x subscript 2. To get 9 by itself, or to get x2 by itself, they divide by 9 on both sides. 36 divided by 9 is 4. Let's try one ourselves. Y varies inversely as x, and y equals 5 when x is equal to 12. Find x when y equals 3. The key word here is inversely. So that means I'm going to be using the product rule for inverse variation. So I have 5 times 12 equals my x times 3. 5 times 12 is 60. 3 times x is 3x. And to get x by itself, I divide by 3 on both sides. Our x would equal 20. So making sure you're using the correct formula will guarantee you that you will get the right answer as long as you put the correct numbers in the right place. Whatever they give you first, treat that as your x1, y1. What you see, the second part, that's your x2, y2. Next one. If y varies inversely as x and y equals 3.5 when x is 20, find x when y is 10. So I have 3.5 times 20. There's my x1, y1. Yes, I know I switched these two numbers around. That is okay. And then here, I'm going to put my 10 first, just because normally you have your coefficient first in front of the variable. So now I have 3.5 times 20. 3.5 times 20 is 70. 70 equals 10x. To get x by itself, I divide by 10. X would equal 7. What about the graph of an inverse variation? Remember when we talked about direct variation? Direct variation, the graph goes right through the origin. But for inverse variation, you can see in the example to the right, in the graph there, that we have two parts, and they're in opposite quadrants. And so when we solve this, we are going to be probably using a formula, and we need to find the constant first. So they're going to give us an x and a y. Like here, they gave us our x and our y. To find the constants in inverse variation, you take your x and your y and you multiply them. And so they multiplied them. 8 times 3 gives you 24. And then you plug it back into the original equation of y equals k divided by x, because you're finding the constant. And this is the equation that you're going to use. You will now then substitute x variables in for x to solve for y. And so that's what they did here. And you need to make sure you use both positive and negative numbers here. So here, in order to stick with whole numbers, they use -6, -4, -2. They could have used 1, but if they used 1, then you're going to have a big y value of 24. So they're trying to keep the numbers small. You notice where it's 0. 0 is undefined because remember you cannot divide by 0. And so you can't have a point on the y-axis. And you'll never get x equaling 0. So it never touches the y-axis or the x-axis either. And so you plot your points and you can see that you have two curves in your graph. So let's look at one ourselves here. You need to find the constant here. So write an inverse variation relating x and y when y is 6 and x is 2. And then graph it. 6 times 2 is 12. So the constant is 12. I'm going to put 12 in for my equation. And here I already created some x values. So I used the smallest one that I could use. Now my graph that I have on the right hand side doesn't give me all the way to 12. So instead of doing +4 or -1 and +1, let's make this a -4 and this a +4. Now let's fill this in. So 12 divided by -3. 12 divided by -3 would be a -4. 12 divided by -2 is a -6. 12 divided by -4 is -3. Then I have 12 divided by 4 is 3, 12 divided by 2 is 6, 12 divided by 3 is 4. I can come over here and plot these on my coordinate plane. So -3 and -4 would be here. -2 and -6 would be here. -4 and -3 would be here. If I would have used 6, -6, 12 divided by -6, 12 divided by -6 would be a -2. So I'm going to put that one right here so you can already see where my curve is. And then I have 4 and 3. So 4 up to 3. I got 2 and 6. I got 3 and 4. If I wanted to go to 6, this would be 6 and 2. You can see my curve. So the more points you have, the easier it is to see the curve there. You'll notice I can't have 0 because I can't divide by 0. And the last graphing one. Solve for this one when y is half, x is 8, half of 8 is 4. So I'm going to put 4 here. Here we're going to have some fractions here, and that's okay. If we didn't want fractions, instead of using -3, maybe I'll use -4 here. And I'll use a +4 here. If you want to keep the fractions in there, you may. That's up to you. So 4 divided by -4 is -1. 4 divided by -2 is -2. 4 divided by -1 is -4. 4 divided by 1 is 4. 4 divided by 2 is 2. 4 divided by 4 is 1. Now I can plot these on my coordinate plane. So I got -4, -1, -2 and -2, -1 and -4. So it's going to get close to the axes, but it will never cross. And then we got 1 and 4, 2 and 2, 4 and 1. And then draw our curve. And there's our graph for inverse variation. Now let's take a look at some application word problems. A truck driver is delivering goods from one state to another. Her speed is inversely related to her travel time. So right now her speed would be her y, and her x would be the time. So her speed varies inversely. If she is traveling at 55 miles per hour, it will take her 13 hours to reach her destination. How long will it take her if she travels at 65 miles per hour? Here, a hint, use the product rule for inverse variation. And that is your x1, y1 equals x2, y2. Another way of doing this one is, since we're dealing with rate, time, and distance, rate times time equals distance. Distance is actually your constant. So you could actually do rate 1, time 1 equals rate 2, time 2. If that helps you, you can do it either or. So let's put in, so 55 miles per hour would be our speed, so our y. So 55, she'll get to her destination in 13 hours, which is our x. The distance is going to be the same no matter what, because they are traveling the same direction. So here you do rate times time equals distance. You're still going the same distance, it's just the amount of time that you're taking and the speed that you're using. So that's why I'm having them both equal to each other. So the rate times time equals the rate times time of the other. So now we have 65 miles per hour. We need to find your x subscript 2. So 13 times 55 gives us 715 equals 65 x x subscript 2. To get x subscript 2 by itself, divide by 65. And we get x subscript 2 equaling 11. Or it would be your time 2, your t2 would give you 11. And our last one here. Sierra found an inverse relationship between her hourly pay rate and the number of hours she must work. So pay rate is your x, and number of hours is your, or pay rate is your y, and your hours is your x. If she worked 7 hours for $8 an hour, how long will she work at $10 an hour to earn the same amount? So 7 times 8 equals your $10 times your, we could just say we're looking for the amount of hours. So the hours is your x, so I'm going to put an x here. So again, we're using x1, y1 equals x2, y2. So 56 equals 10x. Get x by itself, divide by 10. X would be 5.6 hours. And since they're asking you everything is in hours, you should have your answer in hours. So 5.6 hours. That's our lesson today on inverse variation.